तो इलेक्शन में पोलिंग बूथ में जाना पड़ता है या ऑफिस में, काउंटिंग में, सब जगह में।
बहुत दिक्कत सर, 2 दिन बाद तो उसका अभी रिलीज हुई है।
अच्छा अच्छा।
हाँ।
ओके।
और सर डिनर विनर कर लिए?
हाँ हाँ, डिनर हो गया।
अच्छा अच्छा, चलो बढ़िया है।
चलिए हम स्टार्ट करते हैं।
हम्म।
Can see my screen? ओके, मैंने एक काम किया आज, एक्चुअली थोड़ा टाइम मिला था, तो एक मेरा एक YouTube चैनल बनाया और उसमें कल का वीडियो ना उसमें डाल दिए हैं। अभी देखते हैं आगे, वैसे अगर टाइम मुझे मिलता है तो ऐसे ही करेंगे।
जी सर।
Someone is new today. Hello, Salim. Hello, Salim. Hello. Can you hear me? Hi, Firdaus. Sorry.
Yes sir.
Okay. So I can hear you. Hello, Salim. I think you are mute if you are talking. Okay, anyhow, we will do a little bit tweaking of yesterday's program. We did one temperature control, right? So how we can use the same logic to do other kind of application. For example, actually many times we will see that one code we have written for one thing, but the same code can be used for other application as well. For example, yesterday's one, it was just simple one-off control, turning off the heater and turning on the heater with a few few seconds of gap. Similarly, same logic if we write and try to do something else, like for example, flashing light. In almost many system OEMs controllers, we used to have flashing that installed on top of the machine with different colors like red, green, or orange, to indicate different things. Maybe red for fault, orange for alarm, and green for something is running, like machine is on. So those flashing light, we can actually use the same logic to do the flashing light application. So here I will actually do the same thing and try to use the FB. Okay. I just delete this block. We'll start again. Anand Kumar, I think he connected. Hi, Anand. Hello, Anand. Okay.
Hello, sir. Hello.
Okay. Hi. So today we are doing simple application that yesterday I did one temperature controller. So sometimes I'm just showing how we can use the same code in another application uh, uh, with the same code. I mean, you don't have to change anything. We just can copy the code in different block and use it for different purpose, but the code is the same. So this kind of situation also can happen many times. So
It will definitely. It will be interesting. Thank you.
so that here I have created one project. I have not given any name here. Okay, we can save it later. I will create a block, like a function block here, and name will be like flashing. Then ST programming language and add. What I will do, I will give some input. For example, start, and then or like enable, you know, enable, then bool, and then we have output like here flashing out. This is also bool, and here because we are trying to do the flashing application, so we need 2 timer. So we need 1 delay, and then 1 delay is the T on. Yesterday we actually tried to do. Okay, so yeah, actually I have uninstalled and installed this Codesys. We had problem with this timer yesterday, and we found that standard library, properly not installed. So I reinstalled the whole software. T on. Okay, so this is on delay and off delay. This is T on means timer, on delay timer. So if we go over this T on, you see the definition of this block. Function block T on implements a timer with a turn on delay and all the details variable required for this. So what we will do, we will flashing out, assign what enable. But this time we will do one thing. We will use the same block that yesterday we used, set and reset block instruction, enable, and then pressing out, reset equal to not. Okay, so enable, and this should be enable. Then and we'll use the timer here. So the reset should be done after the flashing light is on. So what we will do, first we will enable the flashing light. So enable should be done after kind of one delay timer is elapses. Maybe we will give some 1 second delay. Later we will put code in here. So I'm just adding this code here first. On delay, and then okay, why it's not coming? Okay, because I have not made this on delay. And when this on delay should start, it should start immediately after we enable the system. Enable, what is this? Sorry. In equals to this, and then PT is the preset time, equals to, let's say, 1 second. So enable, and then when timer is run for 1 second, then we turn on the flashing out light. And once it is enabled, and then we will run another timer. Okay. I should not put here. Actually, I should put it here, and then off delay. Off delay timer should actually start after flashing out. The light is on. So it's a second timer, and then PT we will assign something like another second. T 1 second, then close. Maybe we need to modify something. I'm thinking of on delay timer should start when this off delay timer is kind of not on. Dot Q. This is not on, then it should start, and then we will do this one. Dot Q. This timer is finished. 1 second running. We set this one. So once we set this, we start this timer. So after this timer, we get this is done bit. So we will get a done bit of this one, and then we reset this. So once we reset it, this timer reset also, and when it is set, this timer also reset. So this thing continue in cycle. We will test it in simulator. We have a PLC here installed, it's running. So what we will do, we will first try to, what is this again?
Semicolon is expected.
On delay, any spelling mistake?
Semicolon is expected in second line. Off delay after off delay dot Q. Semicolon will be there in
Here?
second line. In second line, flashing
Uh,
out, reset, enable and off delay
right,
dot
right.
Q. Semicolon will be there.
Right. But why here it is showing error?
PLC compilers generally generate error anywhere.
There is no error actually.
After that, semicolon, everything is okay.
Now we try to log in. So it's now downloaded. The program is loaded. Here you see program loaded and PLC is in stop mode. Compile is okay. And if we want to see the message, we will see here build complete, 0 error, 1 warning. Okay, and also we have information here. Okay. Now we run this PLC. So this is a start button, like every PLC software we have start, stop PLC, right? So this is PLC start, and this is PLC stop. And if we want to go offline without stopping the PLC, we just click this one, log out. So log out means actually it will disconnect PC from the PLC, but PLC will running. I mean, it's running. We have not stopped the PLC, and we can see it from here. It is running. You know. So now again login. So here login means actually going online. Now it is online, but you know, this block is not running. Why? Because it is not called inside main block. So this is our main block. We have to call here. So again, to edit, we have to go offline and then just do one thing. We declare that flashing variable. Let's say flashing. I put small letter. Then here I put flashing semicolon. So this is now defined inside program, main program. We can call this block. This is now variable, and the type is function block, and flashing function block is the type of this variable. Now we can call this, and when we call, we get, you know, similar kind of you know, help. So we can do one thing. We put a start, you know, in boolean variable. And what else we need? Flashing out, one output is required. We will not assign that. So here I will give a start enable variable equal to start, then close semicolon. So now this block is being called from the main program. If we now go and we can do one thing, another variable, maybe we can assign flashing light bull. Inside this, here we can assign flashing dot this variable. We can assign to this variable to just to check how it's working. Now let's go online. Okay, now this block is now called, and it is, you know, running. How we know this value? You see the black, it is actually online value. Whatever the value inside PLC, this value are showing here. So we can change this variable here, prepared value. So if we click this cell, actually we can change whatever the new value we want to put here. Now if I put true and right click, we have this write value to the device application. So if I write value, this true will be written and assigned to enable variable. Okay, let's enforce means it will force. So it's like a force is actually kind of permanent thing. Once you force, you have to unforce, then only the variable value will be changed. But write is like if you kind of assign by another variable, it will overwrite. Force, once the variable is forced, it cannot be overwritten by another variable. So let's write it. Okay, we have written it, but it's not enable flashing. Oh, we are actually writing here. Instead, we should do here. We start here because this start value is assigned to enable. That's right. So now this is running. You see the flashing light is flashing in every 1 second. So 1 second on and 1 second off. We can modify this value by changing this variable time. So another thing, important thing, when we test the Codesys, we can actually create watch list. watch table in Siemens, and in Rockwell also we have watch table. So in Codesys we have watch list. We can add, we can right click on variable, whichever the variable we want to edit, watch list. So you see flashing dot on delay PT is added in the watch table 1, number 1. So this is on delay. In off delay we also add to watch table, and here two important parameter we want to modify, and something at the same place we want to monitor, then this also we can add to watch list. So how actually this is manual testing is done. So in PLC programming, when developer develops the code and they do the unit testing, so during the unit testing they do this kind of activity. They create watch table and test their logic before sending it to reviewer and to tester. So this is also called kind of manual testing. A manual tester also does similar like this. And now if I want to modify, let's say I want to modify this to 2 seconds or 3 seconds maybe, t then 3 second, enter. This is maybe t 2 second. So I can do that, and then just right click here and write values. So if I write value, it will be overwritten here. It's not overwriting. I don't know why. Let me try again one more time. Okay, I guess we have actually hard coded this logic. Now I understand. This is hard coded here. So because this logic is hard coded and we don't have parameter variable, it's a constant, right? When we assign hard coded value, it is constant, and constant you cannot change. It's constant. Now we will do that thing, how we can actually modify this through the watch table. I can actually declare here some variable. PT is time variable. I can define a timer like T1, then time, or we can define something like T1, T2 at the same time in same line. So here I will, okay, and then I can do something like T has 1 second. So both variable is assigned 1 second at the same time. This is initial value. Let's say this is T1 and this is T2. Now here we need to actually add this T1 and T2 in the watch table. Number 1, add this, add this. Okay, so this we want to modify this one. Okay, so now you see 2 second is modified. I use keyboard here. Keyboard is shortcut is F7, Control F7. So and then similarly I can modify this as well. 3 second. Control F7 to write the value. So now I have modified the timer preset value to 2 second and 3 second. Now you see this one is flashing very slowly compared to the previous timing. Now, why I said this logic can be used in different application. Yesterday, you remember we used temperature controller. So what's the difference here? It's just this one where temperature is compared with one time greater than high limit, another time temperature is less than low limit. So just imagine this flashing out is a heater, a heating element. So when we start heating when temperature is less than low limit of the temperature threshold. So here just we need to add that comparison, a current temperature less than low limit, and here current temperature greater than high limit, and that's it. Rest of the thing we can keep as it is. Then we can copy this code, or maybe we just simply copy the block and then later we modify this little thing, and that way we can use one block's partial code into another block, and then we just increase um, the code. Any question, Anand, Firdaus, Balwant?
No, no,
Sir,
no question.
sir, I was doing calibration of temperature controller last time, sir. Last
Uh,
year, 2003-4. So I know very well, sir, all type of temperature controller, thermocouple, J type, K type, and
mhm.
everything.
Okay, very good.
So Billy board for me, we give Billy board, and thermocouples will generate temperature readings and quick comparison of Billy. And we will 5 milliwatt temperature 100 degree, 10
Hmm.
milliwatt, but this type value.
Okay, okay. Hmm. Okay, I want to introduce two more instruction today. One is for loop. So tomorrow we will have some little bit different example.
Sir, in C language also used for Python language also used for and have been there.
Yeah, so high level language means you have loop. Loop is very important to solve complex problem, array or index and list and all kind of data handling
Yes.
is easier with loop. So for example, in this example, I want to give this a loop, for loop.
Yes.
Here we have, let's say, one variable.
I
How
equal
to we can imagine a variable like f, a variable, um, or maybe pw, power, and then array to define some limit for 0 to 4, then close bracket of real, and We can actually initialize this variable here. For I equals to 0 to 4, do
Now what are we doing?
we are actually writing a for loop to calculate, some average of a few variables.
Okay, okay.
Okay, then we can pwi. So let's say in a factory we have multiple power monitor, and all power monitor is monitoring different section of the plant, and we have stored the power consumption in different variable, and we want to calculate how much total total and average. We can also calculate the total as well as the average. If you want to calculate total, or you can also, I think, do it here. Average is equal to, actually we don't need this to be, we can use either total or average, both should be same. AVG divided by I, this is average. Now if we run this, we have to call this block first within the program block. So we call here somewhere for underscore loop. Now let's download this one. Okay, so we have to initiate actually this one. Initiate means we have to create an instance of this block before we can use it. So let's PLC PW equal to for underscore loop. So this should be PLC PW. So when within a program block, we want to jump to that particular function or function block, we can right click on it and then browse and go to instance to see the current instance. So here we have the program, and we see average is this, because now we have all the power individually stored, all are 0. We have actually 0 result. So I will do one thing. I will put some average value like 10.0 in every variable. Okay. So average will result. Oh, what happened? Control F7. So I force it. Now this is running. Total will continue add because I put no stop. So once 5 is done, I have to actually exit from the loop. Then only it should work. Now the average is calculated 12.5. 1, 2, 3, 4, 5 should be 10, right? Mhm. So why it is 12.5? Oh, maybe it was the middle. Let's reset this one. 12 point.
I think we have to just assign before for loop that
Exactly. Yeah,
total is 0
exactly.
or
So I,
average is 0.
yeah, exactly. So this I have stopped the PLC. Now we have a result which is 0. Okay. And total is also 0. And what uh, we can do, total average I, and then here we have to put something like if I equal to 5, then break. What is this break? Why it's not taking? Exit. It should be break. Why not taking?
No.
Okay, we'll see exit first and then how this exit should work as well.
And at the end, maybe.
And even.
Yes, sir. Exiting की जगह end.
Hmm. We see again the result is 12.5. So first 0 and then why it is happening, because we are dividing by 50 divided by
4. It is
4.
dividing by 4, not
It's
5.
dividing by last digit, this one. So we have to
We have to
actually
divide it by
yeah,
I plus 1.
I plus 1. Just like we have done actually here, I plus 1, then exit. S- but I think this total is still not working uh, because total is continue adding this one. We have actually total because this total we are doing the for loop to calculate the total, right? This average is actually total. We can simply assign this, AVZ before
Before
making
it,
average.
before
This one. So this will give us the total power. So we have here, instead of 50, we have 60. Because, where is the problem? We have no correct average, but we have wrong total. This is another problem because previously there was some value inside our total. I
we can
guess.
assign average equals to 0 before for loop. So during initiation of cycle, it
Hmm.
will be 0 already.
Hmm. So this is not working, huh? Even here we see total. Hmm. So this is why this is that error message you saw. This is because of demo license. So when you install the Codesys and without it is license, so we have the 1 hour limit, time limit. After 1 hour, it will actually go automatically will go to stop mode. So actually, we can restart and do the testing again. Thing is, we have to put the password and log in again. Okay. We did again same mistake. We stop it. We put some value here. This time maybe 5. Same value. Easy to calculate. So this is
Sir,
our part of
sir,
testing. Hello.
we have to assign the real value 10.0.
then for PW.
You mean real value 10.0?
Yes, sir.
It is taking 10 because we don't have any decimal, right? If we put decimal, then only it will take decimal. But if you put 0, 10.0, it will take 10 by default. Or we can do this one thing.
Because sir, question mark is there in PW. It count I5. So
I5, right. So that means it is counting one more, you mean?
the
No,
counting
this is
correct,
the
but
last value. Actually, last value,
yes,
this
sir.
five is when this for loop stop working. So the for loop is working how long? When the I equal to 0 till
Oh,
4.
5.
So when I becomes equal to 5, the loop is no more working actually.
Equal to 5, sir.
Yeah, 0 to 4. So where we have the problem is we have additional one loop is running.
Sir, I equal to 0, I less than 5, 5 plus plus. Then sir, 5 पे जाके रोक देगा ये.
We can try one more thing.
Hmm.
This AVJ we can do here assignment equals to 0. So before running the loop, we assign this variable to 0, and let's see what it makes difference or not. Now we have a little difference, right? I will just repeat again the process I was doing.
Yes, sir. That's what I'm saying, that we have to declare that zero before for loop.
Mhm. So we have actually initialized our average variable. If you see here, go to stop offline. We have here initialize during our declaration, but this initialization is not effective in every scan. It is only effective when the block is called
Yes,
first
yes,
time.
yes.
So when first time it is called, we
Mm.
run the PLC, it is 0, but this program is running continuously, right? Every second, maybe it is running more than few hundred times.
Yes.
So then actually this average value is no more, initializing. So it was actually having some random junk value. It is difficult to diagnose in this way. So these two variable, when we are using the for loop, it is always better to initialize this variable, whatever the variable we are going to calculate. The output variable, we call it output variable. We initialize before we actually use inside the for loop. In this case, actually, if we have different formula for total, we also should initialize total equal to 0 as well here. So we will not have any confusion. So now every time we have write average and write total. And so we have now covered our for loop, and we have also covered what is the possible mistake we can do and how we can do the diagnostic of for loop. Right?
Yes, yes.
Okay. Hi, Anand.
Sir, in Python
Yes.
is very easy, sir, for loop.
Sorry?
In Python language, sir, for loop is very easy, sir. I use many times, sir. For loop.
Yes, for loop is very popular. Actually, very important. If then else and for loop,
Yeah.
these two, I think, maximum used in any programming
Sir,
language.
while loop, do while. Yeah.
Do while loop also used in many cases where you have to define either this or that kind of situation.
Yeah.
In every platform, loop is always similar.
Yeah,
Maybe
almost
its
similar.
syntax is different, but every loop is similar in every platform.
Yes, exactly. Okay. So, any idea what we can cover tomorrow using for loop? You want to cover some example, some project, or some problem where we can apply? This is one example. For example, we have array where multiple similar data. For example, power. And you want to calculate the total power, average power, those kind of thing, or maybe um, in one array you are saving the total flow of oil or tank liquid into one array every day you are saving, and at the end of the month you are calculating the total and daily average consumption. Those kind of application we can do. There could be many application also in the recipe application also we can use this. Okay, I will find out some application tomorrow. I think I will not do anything today. I will stop here. Okay.
Okay, sir, no problem.
Okay.